Okay, I'm assuming everyone can see my screen now. If not, please do let me know in the chat. So we're gonna go ahead and get started. So today's topic for our ISC webinar is EDNS Client Subnet. So I am Eddie Winstead, and we are very fortunate to have Evan Hunt on the call today. He's a longtime BIND9 engineer and one of the primary engineers on our ECS implementation. So we're excited to have him today. So feel free to pick his brain as we go on through the webinar. So as we do with all of our ISC webinars, this one will be recorded. We usually post these usually in about 2 days, sort of depends on if there's any audio difficulties that we need to edit out or anything. But anyway, in about 2 days, we'll have the webinar recording posted on our YouTube channel, as well as on our presentations page on our website. So we will send any of you that are on, or anyone that registered for the webinar, we'll send you an update when we've actually posted it. And we do encourage you to please forward that to your colleagues or anyone you think might be interested in ECS or just DNS things in general. We will do Q&A. As I mentioned, we'll be able to ask Evan a bunch of questions and me as well. Typically, we handle those at the end unless there's something pressing during the presentation itself. So please do enter your questions as we move along. You can put those either in the Q&A or the chat panel, and we'll address as many of those as we can at the end. So these are the things we're going to talk about today. First, I'm going to talk to you about the subscription edition, essentially why we have it, what's included in it, how you can get it, etc. We'll talk about ECS, of course. I'll take you through a couple of the use cases that we've seen our implementation of ECS used for. I'll take you through a few of the configuration knobs, and that'll actually have some detail straight out of the ARM. So one of the things that we get a lot is questions about configuration for features that are specifically in the subscriber edition. And of course, those, there's less detail about that on the web. So part of this webinar is getting that out there in the public forum as well. And then of course, as I've mentioned, we'll have sort of an implementation discussion with Evan, and then we'll take your Q&A. So why do we have subscription edition? So many of you know ISC is sort of this organization that has been founded for the public good of the internet. So we've been in existence since 1994. We've written over or contributed to over 85 RFCs. So we're heavily involved in DNS and DHCP protocol development and then implementation of that protocol. We're most known for our being the author and maintainer of BIND DNS software. We also have ISC DHCP and now Kia as our DHCP software products. However, along with the extreme technical challenges that we've had to meet over the past so many years, one of those other challenges is how do we make ourselves a sustainable organization? We are a nonprofit and a public benefit organization, but we do employ people, and you know, our engineers like to have families and eat and do all the things that other folks like to do as well. So historically, how we've done this is we have sold support and professional services. So typically folks run either BIND or ISC DHCP or Kia in critical internet infrastructure. And a lot of those folks do that in commercial organizations. So sometimes by policy, they're required to have support contracts. And then sometimes it's more of a, a need-based thing where they come to us to buy support and, possibly consulting, help them troubleshoot a particular problem, et cetera, et cetera. Over time of our existence, we noticed this pattern of specific commercial requests, obviously from entities that were using the internet for commercial purposes, but they wanted specific features put into our softwares for those commercial purposes. So this is sort of led to this, what we have now is a subscriber edition. On the Kia side, we have, you know, premium and subscriber hooks. This also provides a way for us to have, you know, an opportunity to put some new features out to tried and trusted parties. And of course, our direct customers are certainly included in that, and get feedback and, you know, experience in how a new feature behaves. So if you haven't heard of it before today, BIND9 Subscription Edition is one of the names. You'll hear some other names as well. If you're actually the technical person that's installing Bind at the command line or however you install it these days, you'll see it named with the -S on the end of the naming string. So for example, BIND9.11.18-S. The other name that we often use is Stable Preview. Many of our customers choose to use the subscriber edition because they usually have corporate policies where they can't implement, you know, the latest version of some software. You know, anecdotally, you know, I worked in this field for a long time. There are lots of people in management positions that say don't install anything with a .0. This can get into sort of a flame war, but anyway, management doesn't want new and unstable code put in, right? Obviously, this could be business affecting. So the side effect of that is you don't get to take advantage of a lot of the new features. So with the Stable Preview, we're able to put new features into stable code bases and have our customers use that stable code base and get access to the new features. So again, you'll hear it referred to as Stable Preview. So historically, what has been included in the subscription edition, many of you will probably know response rate limiting, or RRL. This was a mechanism by which authoritative server providers could limit the damage to their servers if they were being used you know, as a vector in a DNS DDoS attack. This also had the benefit of protecting the victims of those DDoS attacks. Now you'll notice these arrows going into open source. So we put RRL into the subscriber edition first. Again, this is because brand new software, we wanted to see how it would behave and if there were other negative consequences that we hadn't thought of. RRL actually moved really quickly from the subscriber preview into the open source because it was such a critical element in making a much more stable DNS ecosystem for the internet. So again, it's this balance between you know, keeping ourselves sustainable, but if something like RRL, it's not something that we're going to hang on to in our subscriber edition for a period of time, being that it proved to be such a significant security feature. The next one we had is Negative Trust Anchor. This one has also now moved into the open source, but this was a mechanism by which if you were a recursive server provider and you implemented DNSSEC, and then some domain that was DNSSEC signed had a problem with their DNSSEC infrastructure, you could turn off, a Negative Trust Anchor allowed you to turn off DNSSEC for just that one domain. Prior to this feature, you had to turn off DNSSEC entirely, which isn't exactly what we wanted. One of our longtime customers and supporters actually requested this feature, so it went first in the subscription edition, and again, has now been rolled into the open source. Client query limits, yeah, if you were around, I don't know, maybe 4 or 5 years ago, then you probably remember the pain of the pseudo-random subdomain attacks. So there was effort that we did to alleviate this condition on the recursive side, and we put that into the subscriber edition first as well. And again, this was for, we wanted to make sure that it was effective against the attacks, and then we also wanted to make sure there wasn't any negative consequences that we hadn't foreseen for putting these limits in the code. That went pretty quickly as well, and it's would determine again in similar way as RRL that this really benefited the DNS security ecosystem, and that went very quickly into the open source. 2 features that we have today in the subscription edition are umbrella support and ECS. ECS, of course, we're going to talk about quite a bit today. Umbrella support is maybe what exactly you think of. So we have customers that use BIND internally for their recursive name servers, but they have a relationship with Cisco, and so they want to be able to forward, queries, certain types of queries out to the Cisco umbrella servers. So we do have that feature currently in the subscriber edition. You'll notice these don't have arrows to open source. At this time, we don't have plans to put ECS in the open source version. Again, ECS is so far very specific to commercial applications, particularly web applications, and providing content in a much speedier case for folks that are doing commerce over the internet. So at this time, it's not scheduled to go into open source, but we're certainly, we'd certainly be open to hearing your opinions on that as well. So on to ECS. So EDNS Client Subnet, this was defined in RFC 7871. Note that there's been a very long process with defining ECS. So there's been lots of attempts at drafts, and meanwhile, there have been lots of sometimes production deployments. So there's a bit of a hodgepodge with ECS out on the internet. So just be aware of that. But 7871 defines a new EDNS 0 option, essentially to convey network information. So EDNS, very quickly, is extension mechanisms for the DNS. Many of you will know it in terms of its encouragement for deploying DNSSEC. So in the old days, the original design of the DNS limited you to 512 DNS message was limited over UDP to 512 bytes. And so EDNS was a mechanism by which you could extend that to 4096 bytes. This was to allow for larger responses for DNSSEC, IPv6, et cetera, et cetera. But note that EDNS is a hop-by-hop protocol. So this means it's a sort of a server-to-server negotiation for each of this, and each of these activities. So, and then it makes use of optional records. So again, we're still running on the 30-some-odd-year-old DNS, but we're adding these extension mechanisms to make better use of the DNS in today's world. Specifically for ECS, what this allows authoritative servers to do is to return differing answers to recursive servers based on things that the recursive server is providing. In this case, client subnet. Now, in the old days of the DNS, right, we were in a world where clients typically ask either their ISP resolvers the question, those resolvers then went out and got the answers for them, or the clients asked, enterprise level resolvers, and then they went out and got the questions for them. So there was more of a geographic based element to all of this. These days, we have very large recursive server providers. The most common ones you think of course, are Google with 8.8.8.8, Quad 9, and Cloudflare. But the point is, these days, while geography is still part of the equation, it isn't as critical in determining what the network topology looks like. So this is just another piece of data that the DNS authoritative servers can use to provide a tailored answer back to the recursive servers and then on to the clients. Can be safely ignored is just that, right? We have a lot of DNS servers out there that still only speak the original DNS protocol is defined 30 some odd years ago. So if I am a recursive server and I send ECS data or any EDNS data to a server that doesn't want to deal with that, then it doesn't have to, it's not required to. So ECS in BIND9, the subscriber edition, I want to point out that, and this is pretty important, that this is recursive only. So this is only about sending ECS data onto authoritative servers, and then those authoritative servers being able to make choices about what it sends back to bind in this case. Note that we had an authoritative implementation for ECS in prior versions of bind. And remember, I talked about this very long process of getting this defined in the IETF and lots of differing implementations occurring over that time period. This was one of those. So we had an authoritative ECS. It has now been deprecated. And again, at this point, we are not, we're not actively seeking to do an authoritative implementation of ECS. But if you're interested in that, please do let us know and talk to us. So again, so in this, we're sending, as the name implies, client subnet. We're sending some data to the authoritative servers so that they can make decisions on what they're going to send back to us. So note that for the bind implementation, and this is stated in the RFC as well, that this the maximum allowed is /24 for IPv4 and /56 for IPv6. We're going to talk a little bit about the concerns, but I think you can kind of see where we're going here. The DNS is a different world than it was long ago. There are lots of privacy considerations. If I know things about your DNS queries, then I can sort of figure out things about you or your customers or your clients. So this is, ECS is adding to that. If I have access to, to your DNS queries already, then ECS is adding some more data to that. So it's an additional privacy concern. And note that this is intended to be configured per zone. And again, this goes back to the privacy issues. So this isn't a thing where we want to turn on ECS for all queries that are leaving our recursive server. We want to do this on a tailored basis in cases where we're willing to trade off some of the privacy issues for a much more robust user experience, particularly as it pertains to content. And I'll get into some of this more actually on this slide. So there are two primary concerns when folks start talking about ECS. Again, as I've already mentioned, privacy. So again, the maximum is a /24. If I do /22, then I'm adding a little more privacy on behalf of my clients. But the more specific you make those ranges, the more decrease you are going to have in potential client privacy. The other part to this is cache size. So if you think about this, this is all about providing different answers based on some network information that I'm sending to the authoritative servers. So the authoritative servers are going to send me different answers based on that. And so I'm going to have to cache those based on that new delineation, if you will. So for example, if I'm doing that via /24, if a client on the same /24 that I'm sitting on has already asked the question that I'm going to ask my recursive server, and it's within the TTL, of course, then my query to my recursive server is just going to answer from cache. Someone sitting on another /24 using that same recursive server is going to use data from the cache for that /24. So again, the more specific here you configure, potentially the larger your cache will be. A little bit more on caching with ECS. So negative answers, for example, NX domain are cached globally. And by that, I mean, it's in the global cache. So it's not in the cache that I was just referring to in my example. It's not based on the network range, right? So the idea here is basically I can't respond telling one client that something doesn't exist and then respond to another client on another network and say it does exist. So anything that's a negative answer is going to be cached globally. The other thing to know is that any DNS infrastructure types, such as delegations, DNSSEC keys, all those are also cached globally as well. So use cases. So this has been interesting to us, as always. So customers are always fun, right? So large majority of our customers, just want the simple ECS that I've essentially described here, right? I want to be able to pass client subnet data to the large CDNs and have them do tailored responses back to my clients, right? And I'll talk about how that's done in just a bit, but that is the primary use case, and that is what we developed ECS for. Now, it turns out we've run into some interesting internal network cases. So we've had situations where a customer has both control of the recursive, internal servers and their authoritative servers internally, and they're using ECS to provide differing answers internal to their network using BIND9 ECS on their recursive side. I don't have visibility on what they're using for the authoritative. Again, we don't have an authoritative implementation for that use right now. And then we've also seen some filtering internally before external recursion is being done. So I will point out, and in these cases, these are internal only, right? So there are, of course, code is code and numbers are numbers. So while we say there are maximums, /24 and /56, those can be modified. And we've seen in some cases, very specific use cases wanting to do, sort of larger network size, which is, entirely fine if you take into consideration the privacy issues. Again, this is only to be used internally at those larger network sizes. And make sure that none of those, if you do any of that, that it does not leak outside of your network. So to be used with, handle with care. Anyway, it's been a surprising development on our side with folks wanting to use ECS in this way. So on to a couple of configuration options. ECS bits is one of the main ones, and this is the place that you can set network sizes other than the defaults, right? And this is if you use ECS bits, this is a global option, so this will be for everything that you're doing with ECS. You can override some of this on the and you'll see this on the next slide. But in general, if you set ECS bits here, that will be globally for any of the ECS queries that you're sending out. Default values, again, are /24 for IPv4 and /56 for IPv6. So ECS zones, and you'll see I've actually got a namely.conf snippet here. In this example, what we're saying is for example.com, I want to send a /20 in v4. I don't want to send any ECS related data for this excluded.example.org. And then for example.org itself, I want to send /22 related data and /48 for IPv6. And then I'm also going to send ECS data for example.net. And since I'm not specifying the bits here, it's going to use the global option. So in our example that we're using here, this will be a /24. And, a lot of times when people look at this, there's a bit of a freak out moment in that, oh my goodness, now I'm going to have to add all these zones that I want to send ECS data for. It turns out that's not entirely true. We have lots of DNS trickery at our disposal. So what usually happens here is there are just a few of the major CDNs, right? Akamai, Amazon, Fastly, the usual ones, right? So how that usually works is if you do a dig, for example, of www, whatever your content provider that first comes to mind, what you'll usually see is this: if they're using one of these CDNs, you'll see that it returns a CNAME, and the CNAME points into the CDN's namespace. So if you have those CDNs in your ECS zones, then those queries for those domains are going to all get ECS tailored responses, even though you don't have explicitly put all those zones into your namely.com. So I do have sort of a homework assignment for you. So if you have a terminal window handy, just go ahead and dig for whatever, www, whatever site you go to a lot. And you'll start to see some of these CNAMEs, and they'll point to, like I said, the usual suspects. And when you see that in place, then that means that they could be used to give more tailored responses to your clients. A lot of you, in terms of operating recursive servers, have forwarding in place. So this is just to let you know that you can also do forwarding with ECS tag queries. These are ACL controlled. So, you know, however you're used to setting up ACLs in named.conf, the same one will apply, sorry. And again, in this case, the default for ECS forward is none. But in general, just know that you can do forwarding with ECS. It requires a little bit of tinkering with the config, but really not much at all. And so now we're going to open it up for discussion with Evan Hunt. So a lot of you already know Evan. So, you know, he's been a long time developer here at ISC. He was one of the primary members of our ECS implementation team. So we're going to talk to him some about implementation and any of the gotchas. So yeah, I'm excited to talk to Evan. And with that, Evan, can you do an audio check?
Here I am. Can you hear me?
Oh, excellent. Yes, I can.
Cool.
All right. How are you today?
Oh, doing all right. Can't complain. Not without feeling
good.
guilty about it anyway.
Okay. Very good. All right. So Evan, couple of questions for you. Anything you'd like to add or, you know, correct or anything of what I've already said so far?
Nothing of major importance.
Okay. Excellent. Always good to hear. Okay. So how did you and the BIND team go about planning for the implementation of ECS and BIND?
It was actually somewhat different from our usual approach. ISC usually takes a agile, I guess, approach to development planning. I'm using agile as an adjective without a capital A
Okay.
or a little trademark symbol. In this case, we were working with a particular customer who particularly wanted this feature and had a particular set of requirements. And they contracted with us first to do a requirements analysis with them and write a rigorous requirements document, which is not the usual approach that we take. We usually kind of develop as we identify requirements and develop sort of in synchrony with each other. Yeah. In this case, they wanted detailed planning in advance, which turned out to be very helpful. We subcontracted the planning work to Synodon Internet Technology. Sarah Dickinson went over their requirements and the requirements that fell out of the existing ECS draft at the time, and wrote up a set of numbered requirements that the customer then okayed, and we then developed a plan based on meeting each of those requirements in sequence, and developed a test plan. Which, if you're in the habit of running the system tests on BIND, and if you have the subscription branch, you may have noticed that the output from the ECS system test looks rather different from the others because it has specific requirement numbers identified in each test case. In any case, it was two primary developers, myself and Mukund Sivaraman. We divided the work up. Mukund worked on the cache and I worked on everything else. And we each reviewed the other's work. And Curtis Blackburn did the test case development.
Ah, excellent.
It was about a 3 or 4 month job, I think. 2 or 3 years ago, 3 or 4 years ago, I guess. They've been unusually long years, so the details have gotten fuzzy.
Yeah, I agree. Did you run into any unexpected problems as you were doing the implementation? Anything fun?
To be honest, at this point, the memories have all been edited into a very clean version. I'm sure there was a blooper reel at some point, but I don't recall.
Okay. All right. Now you mentioned sort of a more detailed test plan than we usually have for features. Can you talk about? I would
say a more rigorous one.
Rigorous, yeah.
We had a very specific set of identified and numbered requirements, and rather than writing tests for code as we wrote it in a sort of a make sure we exercise all of the code and make sure we exercise both sides of every if statement and so on, which would be the approach we'd usually take. We went at it with make sure the code does this thing that we specifically said in advance it was going to do, make sure it does that thing. And then we came up with a set of miscellaneous additional tests just for code coverage and to check pathological cases and things like that.
Gotcha. Any surprises in how users are operating ECS?
You already mentioned the big one.
Okay,
the one that hit me entirely out of left field was the person saying we really want our resolver to send as much identifying personal information as possible to the upstream server. That seemed insane, but it turned out they had a good reason, because that personally identifying information was not leaking outside of their corporate campus. It was used for some sort of internal filtering process that was I can't say that I understand the corporate plan that was behind it, but it actually did make technical sense.
Yeah, exactly. Yeah, and I think that was a shocker for me as well. Evan, you and I talked about that, and I think in ECS zones it was essentially the dot was put there, which works, but in general we do not recommend.
Right. Yeah.
Unless you have this very specific internal case.
Yeah, because if you have a dot in there, that means every zone everywhere on the internet is going to receive ECS client information, and that means if you operate a resolver, then information about your clients is getting leaked to every authoritative server operator.
Exactly.
All of which is, the development of ECS in the first place at the IETF level was always controversial, and I was actually on the side that was against it. So it was ironic that I ended up developing it, but life goes that way sometimes.
Yeah, it does. Yeah, and then the other thing about a resolver sending all that ECS data out, like if you put in dot, then the majority of authoritative servers can't do anything with it anyway. So it's a sort of a no-op. You're sending possibly identifying information with no benefit in that case.
Exactly.
Yeah.
So Eddie, I remember, this is Vicki, I remember that case where the customer wanted to use ECS everywhere internally, and it was a big enterprise where they wanted people to use the same name in different departments and get a department specific site.
Yeah, exactly. Which typically we would think of as using views for, but in that particular case, they wanted to use ECS, which was interesting. I mean,
the thing is, they also wanted this to apply to every query. They wanted the ECS to be going on every query, because it would be passed to a forwarder, which would be passed to a forwarder, which was going to do some sort of egress filtering. So there was they wanted client information to be passed along at the egress filtering point, and I think that's why they had it turned on for everything and with the maximum address.
Yeah, that makes sense. Now, Evan, you were also involved in the implementation of GeoIP with BIND. Could you talk about some of the differences in use and behavior between GeoIP and ECS?
Yeah, I was. So GeoIP and ECS, there's a little bit of overlap in the Venn diagrams between them, in that they're both about giving different answers to different people. In terms of BIND, GeoIP is related to authoritative queries. And to explain what it is, in case anybody doesn't know, it's a database of IP addresses or networks, subnets, with geographical information associated with them, and things like AS numbers or corporate identity. So you have a client contacts you from an address 149.20.15.12, and that gets sent out by named to a local database lookup and finds out that 149.20.15 belongs to ISC and it's in Redwood City, California. At that point, when named is choosing which view to answer a query from, if you have split DNS, named can send that query out. It can check against certain answers from the GeoIP database. For example, you might have a view that is specific to Europe. And if the IP address identifies itself in the GeoIP database as being in Europe, then that view would be selected, and if not, some other view would be selected. when we had authoritative ECS support in named, which we still do in the current subscription edition, but we won't in the next subscription edition, and we don't have it any longer in the open source stable branch. When we had that, it was somewhat similar. You could have a view that specified that it would match any ECS network if a client supplied an ECS value. If this view would be matched if the ECS value was 149.20/16. Also, when we had that in place, the ECS value that was supplied by the client, if there was one, could be used to do a GeoIP lookup. So if you're running a big centralized resolver, some client sends in a query that includes a client subnet identifier. That client subnet identifier can then be looked up in the GeoIP database to find out whether it's in France or whatever. And then that would be used to select a view. So there's a little bit of overlap between them, but when we removed authoritative ECS support, which I should probably talk about why we did that at some point. When we removed authoritative ECS support, we also removed the linkage between GeoIP and ECS.
Gotcha.
So there's no longer, in current code, there's no longer any real overlap at the code level between GeoIP and ECS, but they are different approaches to the same general idea of grouping different people into different answer sets. So I'm going to anticipate that somebody might ask and answer the question, why did we remove the authoritative support? The answer is that it was originally written purely experimentally, just as a way of making a version of a server that you could play with ECS and test it out in different scenarios. And it was never really deployable. The way it worked was you would specify ECS subnets at the view selection level. You could have a view that was selected based on where the ECS client was. And then the answer would be sent back with a scope length indicating what if you specified 149.20/16 in your view selector, then /16 was going to be the level of the scope with which the ECS response could be used. I'm getting into the weeds technically, sorry.
No worries.
That turned out not to be the right way to do it. It was correct at the time we wrote it, but then the ECS draft continued to change and evolve in response to the various controversy at the IETF level. And by the time we deployed the recursive ECS support, our authoritative ECS support was based on a version 6 drafts ago. They didn't really play well together. The authoritative one wasn't really right. And what was worse is that if you actually want to use this thing, any real logical use case, you would have to have many, many, many views, one for each ECS subnet that you want to have a tailored response for. It could be hundreds or even thousands of views, and that just doesn't scale very well. It takes up an enormous amount of memory. It slows down query processing. It's not something anybody who wasn't just playing around in a lab would ever use. So we decided to simplify the code base and remove areas of code that might have problems that nobody was going to be sanely using anyway, and so it's gone now.
Now you mentioned it's still in the subscriber edition. One thing I failed to mention earlier is that currently the subscriber edition is based on 9.11. That's, we expect by the end of the year is going to be based on 9.16. Is that when that code is going to come out, Evan, or is that coming out?
Yeah, that's correct.
Okay.
So we didn't remove the authoritative support from the 9.11 branch. That is still our long-term support branch, and therefore it's the branch that the subscription edition is based on. Around the end of the year, we're going to be updating long-term support to the new stable branch, which is 9.16. So that at that point there will be a 9.16 subscription edition, and the 9.11 subscription edition will reach end of life.
Okay, understood. Thanks for that. That was all the questions that I have. I'm trying to see if I stop sharing, do I get to see the Q&A? Oh, let me see here. Okay. All right, here we go.
Eddie, there's nothing actually in the Q&A yet,
Okay.
but there are some questions in the chat if you go through the chat.
Okay, let me see. Now, when I'm doing this, Vicki, can you see the actual chat screen, or do you still see the slide?
We're not seeing any slides.
Okay. So here's one from Alton. Does BIND by default exclude internal IP space from being passed on through ECS?
No, it doesn't.
It does not. Okay. Oh, I see Evan has answered a lot of these.
No,
sorry, I'm just catching up.
Only just the one.
Okay. Okay, our buddy Joe asked, aside from growing cache size, are there any other noticeable performance hits on the server?
That's a good question. Not too bad. There is a little, but the way the cache works under ECS is if a response comes back and it is tagged with a non-zero scope length, to get into technical weeds again. In other words, if the response comes back from the authoritative server saying that this response is specific to a particular network, it's not global, then the cache database normally contains a list of our data sets that are at a given node, and a list of and a sort of a negative or data set that says here's what we know isn't at that node. Now, in addition to that, it also has essentially a little radix tree called the IP tree in our local parlance, which is a fast bitwise lookup tree structure that gives you a set of our data sets for the particular subnet that that we're matching. So if you have if you get a query from a client and it has the same subnet information as a previous query from a client, which had a tailored response from an authoritative server, then you're going to get into the IP tree and you're going to do a fast lookup. It's order one. It's a radix tree, so it's very quick. Fast lookup to see if there was any cached information that was specific for your network. If not, then you'll see if there's any cached information that's global. And if not, then you can then you trigger recursion to get the answer that the person was looking for. The IP tree is very quick. It does add a little bit of performance overhead, but it's not very noticeable.
Okay, excellent. John asked, and Evan, you can read along in the chat if you like, but I'll read it out loud for everyone's benefit. Since it is the case that certain authoritative operators prefer ECS, was or is there any discussion about how to tag ECS onto queries going to specific regex mapped authoritative servers? For example, star.akamaiedge.net to send ECS along with all queries that go to name servers that contain akamaiedge.net in their NS results. Or am I missing some reason that this is not viable as a way to restrict ECS leakage and reduce management work maintaining the domain list?
Well, it wouldn't be regex based. Probably it would be it would be the same way that ECS zones is currently set up, which is akamaiedge.net, anything in that name. We wouldn't use a star or regex processing. That said, however, I believe that ultimately, okay, this is getting into something that I last thought about a few years ago, and so I'm fuzzy on the details. Okay. I do recall that we discussed whether we wanted to base the use of ECS on the query name or on the NS server name, or both. I think that's what you're asking. And I think we settled on the query name being the right thing to do, but I'm sorry, I'm afraid I don't remember why. I do remember that being a thing that we discussed at length, but I cannot recall what the pros and cons were. Sorry.
Hey, no worries. Yeah.
Eddie, I mean, Evan, I seem to remember that back in the days when people were arguing about ECS and DNS ops, that there was some discussion about creating a a shared whitelist of major providers that wanted ECS. I remember pretty distinctly that that devolved into, you know, a political argument, but I think that may have had something to do with this question. There was a lot of discussion about who decides who's on there.
In this particular case of this particular question, though, I think what we're talking about is when we're whitelisting domains to which we're sending ECS, are we whitelisting it based on the query name, or are we whitelisting based on the name of the name server? And I'm sorry. I remember having that conversation, and I don't remember why we settled on the answer we settled on.
It's quite all right. Possibly, John. Actually, John, I think we have a meeting with you coming up, and maybe we'll have the answer to that tomorrow. So we'll follow back up with you on that one. All right, Vicki, have I missed any questions that have come in?
Not really. I just enabled John to talk if he has a follow-up question, because I'm not sure that we totally understood his question, but maybe. There was a little bit of discussion about whether or not some servers don't react well when they get EDNS options. This has been a problem for years. It was the subject of one of the flag days. Andreas commented that Microsoft DNS has a problem with that. So most of the rest of what's in here are more along the lines of comments than questions.
Okay. Vicki, do you have any questions that you'd like to pose to Evan? Or me?
Well, I do have, I have two questions for the audience, actually. So the first is, and I think maybe John might have confirmed it, I've heard a couple of reports that in setting up peering with tier 1 providers, sometimes they are requiring that you send them ECS. And I'd love to know if this is really a widespread thing. The other thing I think is we are very interested in what these alternative applications are for ECS. So as Eddie described, it was originally designed for locating a geographically close content server, especially for you know, video content, something with a lot of high bandwidth content. But people are clearly leveraging it as sort of a more general purpose way of tagging queries for you know, differential handling. And I think Ray Bellis from ISC has an early draft of some an alternative for this kind of tagging. And so I'm very interested to hear what are the other applications that people have.
And so Joe responds to that, Vicki, regarding peering requirements. We haven't noticed any peering requirements. There have been some pushback on transport costs if it's enabled or not. That's interesting.
Yeah, that is interesting. And you know, Joe probably has a lot more leverage in peering relationships than some smaller ISPs.
Correct. John adds, to additionally complicate matters, authoritative providers who want to consume ECS will often not trust ECS from just any origin, and they want to vet the origin with their own criteria before they accept or use ECS results. And I agree, he says that's a bit of a mess. I've not heard anything about the peering issue. That would be unexpected given the controversial status of privacy in ECS. And this also implies they have a full list of IP origins of recursive servers, recursive resolvers.
Yeah, this is John from Quad 9. So yeah, that implies that's a bigger problem, of course, for people like Quad 9 that run large arrays of recursives. But even an enterprise might have 5 or 6 different egress points for their network, And if they're using ECS, then they're going to have to go through that whole process. So it's questionable how many enterprise or even small ISP operators are going to want to have to do that that relationship building with every single CDN who has these criteria. And not all do, right? It's just a few who have said that they don't trust ECS from any origin. And that's to avoid people from, and one thing that we didn't go into in this call is how ECS can be transmitted through different layers of forwarding caches. And you know, each cache, of course, and you did say this, each cache makes their own decision on whether they edit that data, minimize the subnet masking, or in fact, completely rewrite it. And so if you're in France and you want to get a content that's only permitted from IP addresses in the United States, you could try to spoof your ECS, and that leads to these big trust issues between recursive operators, ISPs, and the CDNs, and it really is, it's kind of a mess. So.
Yeah, agreed. Yep.
Okay, well, it seems like we don't have any other questions. So, you know, we'll just wait a sec if anybody has any more comments or questions they want to throw into the chat.
And if we don't get any more questions, just note some contact information for us. If you do want to talk about ECS and BIND, please do hit us up on our contact page or send email to info@isd.org. Most likely, I'll be one of the people that you end up talking to about it. So I look forward to hearing from some of you about this topic.
Okay, well, thank you very much, Eddie and Evan.
Yeah, thank you all. And thanks John, for jumping in, and thanks all for joining. Take care.
Have a good day, everybody.
All right, thanks, Evan.